Good morning, dear students. In the previous lecture, we have gone through various searching techniques named as linear search, binary search. Today, we will see one more searching technique named as Fibonacci search. The requirement for Fibonacci search is array should be in the sorted order, exactly similar to binary search. As we have seen, for binary search, we have first sorted and accepted input array. Same thing we have to perform here. That is the requirement of Fibonacci search, binary search and Fibonacci search is array should be in the sorted order. Again, both binary search and Fibonacci search, both techniques belongs to divide and conquer strategy. As in divide and conquer, we divide entire problem into sub problems and we try to find sub solutions and so on. In Fibonacci search, first we accept an array of size n. We sort the given array, then we accept key element. Once we accept key element, we generate a Fibonacci series up to some extent. Once we generate Fibonacci series, we calculate value m. Value m is the value from the Fibonacci series which is immediately greater than or equal to n, where n is the number of elements into the array. Once again I repeat, first we accept an array of size n, we sort the given array, once we accept key element, once we accept the key element, we generate Fibonacci series up to some extent. Once we generate Fibonacci series, we calculate number m from the Fibonacci series, and that number m is nothing but it is the value which is immediately greater than or equal to n. N is nothing but these are number of elements. It is number of elements from the given array. Once we calculate m, its two preceding values are considered as m1 and m2. First we calculate m from the Fibonacci series. That m is nothing but it is the value who is greater than or equal to n. Once we calculate m from the Fibonacci series, its two preceding values are considered as m1 and m2. Once we calculate m1 and m2, we directly compare key element with a of m2 plus offset. In the first iteration, offset value becomes 0. Once we calculate m, we generate m1, m2, those are preceding values of m. Once we calculate m1 and m2, we compare key with a of m2 plus offset in the first iteration, offset value is 0. Now there are three situations. Either key it may be equal with a of m2 plus offset. If this is so, we can say key is found. If it is not equal, now either it may be greater than or it may be smaller than that of a of m2 plus offset. If key value is greater than that of a of m2 plus offset, at that time we update m as m1. If the key value is smaller than that of a of m2 plus offset, at that time we update m as m2. Once we update new m, again we recalculate values of m1 and m2. Once again I repeat, we compare key with a of m2 plus offset. If once we compare, we may have three scenarios. First scenario is that key may be equal. Once it is equal, we can say key is found. Otherwise, key value it may be greater than that of a of m2 plus offset. If this is so, we update m. Now it is equal to m1. And if key value is smaller than that of a of m2 plus offset, at that time we update m as it is equal to m2. And once we generate new m, again we recalculate values of m1 and m2, and again we repeat the same procedure to compare key with a of m2 plus offset. Again, if it is equal, we print as key is found. Again, if it is smaller or if it is greater, we update m, and we repeat this procedure till m is greater than 1. Once this condition is not true, definitely we can say key is absent. So this one is the technique. Let us solve several examples so that we will let us solve several examples so that the concept will get more and more clear. For example, suppose this is an array. Already I have taken sorted array. Okay, the n equal to 5, that is there are 5 numbers, therefore n equal to 5. And suppose I would like to have search for 60, therefore key becomes 60. Once we accept key, here I generate Fibonacci series 0, 1, 1, 2, 3, 5. No need to write Fibonacci series more, because we are not interested to write Fibonacci series. We are interested in m, and that m is nothing but it is the value from the Fibonacci series which is immediately greater than or equal to n. In this case n equal to 5, and the value who is greater than or equal to n is 5. Therefore we pick up 5 and we set it to m, therefore m equal to 5. Once we calculate m, its two preceding values 3 and 2, we consider them as m1 and m2 respectively. m1 equal to 3, m2 equal to 2. Once we calculate m1 and m2, we directly compare key with a of m2 plus offset. In the first iteration, no need to consider offset value because it is 0. Why this is so? Because start index of 20 is 0. So in the first iteration, no need to consider offset value. Okay, we have now m, we have m1, we have m2, we have key. Now we compare key with a of m2 plus offset. Offset is 0, that is key is 60 and m2 value is 2. So we compare key with a of 2. A of 2 is 40, key is greater. I already have told if key is greater than a of m2, key is greater than a of m2, we update m as it is equal to m1. Previous m1 is 3, therefore we update m equal to m1, which is equal to 3. Now new value of m is 3. Again, from the Fibonacci series we have m as 3, therefore preceding two values are 2 and 1, therefore m1 equal to 2, m2 equal to 1, m1 equal to 2, m2 equal to 1. Again, we compare key with a of m2 plus offset. Key is 60 and m2 is 1. Therefore, we compare key with a of m2 as I have told m2 is 1 plus offset. Offset is nothing but now it is index of 40 and index of 40 is 2. Therefore, we compare key with a of 1 plus 2, where 1 is value of m2 and offset is nothing but it is index of 40. Therefore we compare key with a of 3. Again, a of 3 value is 50, key is 60, key is greater. Therefore again we update m as m1. M1 value is 2, therefore m equal to 2. As m is 2, m1 is 1, m2 is also 1. Again we compare key with a of m2, which is 1 plus offset. Offset is nothing but now it is index of 50 and index of 50 is 3. That is we compare key with a of 1 plus 3, where 1 is value of m2, 3 is offset, and a of 4. A of 4 is 60. As we see, a of 4 is 60. Again, key is also 60. Here we can say key is found. So this is the technique. Once again I repeat the entire technique. In the first step, we accept an array of size n. In the second step, we sort the entire array. In the third step, we accept key element. Once we accept key element, we generate Fibonacci series up to some level. Once we generate Fibonacci series, we consider the number m, which is immediately greater or equal to n. Once we generate Fibonacci series, we select a number which is immediately greater or equal to than n, and we set that value to m. Once we have m, its two preceding values are considered as m1 and m2. Once we have m, m1, m2, we compare key with a of m2 plus offset. In the first step, no need to consider offset value. If key is equal, we can say key is found. If key is greater than that of a of m2, at that time we update m as m1. Otherwise, we update m as m2, and we continue this procedure till m is greater than 1. Once this condition is false, definitely we can say key is not found. Again, Consider another example. Here I have considered an array of size 11. Already array is in the sorted order, and I would like to find key as 85, therefore key equal to 85. Now I generate Fibonacci series 0, 1, 1, 2, 3, 5, 8, 13. No need to write further Fibonacci series because I am interested to find value m from the Fibonacci series, and that value is nothing but it is the value which is immediately greater than n, or it is equal to n is 11. So the value from the Fibonacci series who is immediately greater or equal to n is 13. Therefore we select that 13 and we set it to m. Therefore m becomes 13. As m is 13, preceding values are 8 and 5. We update m1 and m2 as m1 equal to 8, m2 equal to 5. We have m, we have m1, we have m2. Therefore we compare now key with a of m2 plus offset. In the first step, no need to consider offset, as offset is the index of 10 which is 0, so no need to consider. So key which is 85, we compare it with a of m2. M2 is 5, a of 5. A of 5 is 60, key is 85, key is greater. As key is greater, I already have told we have to update m as m1. Previous mn is m1 value is 8, therefore m equal to 8. As m equal to 8, preceding values of 8 are 5 and 3. m1 equal to 5, m2 equal to 3, m1 equal to 5, m2 equal to 3. Again we compare key with a of m2 plus offset. m2 value is 3 and offset is nothing but it is an index of 60, and index of 60 is 5. Therefore we compare key with a of 3 plus 5, where 3 is the value of m2 and 5 is the offset. So a of 8 is nothing but 85. Key is 85. Yes, both are equal, therefore we can say key is found. In this way this technique works. So let us analyze the technique. Before analysis, again I would like to revise the things which we have seen up till now, that is the algorithm. First, we accept an array of size n. We sort the entire array. We accept key element. Once we accept key element, we generate Fibonacci series up to some level. Once we generate Fibonacci series, we calculate value m. M value is nothing but it is the value from the Fibonacci series which is immediately greater than or equal to n, where n is the size of array. Once we generate m from the Fibonacci series, its two preceding numbers are considered as m1 and m2. Once we have m1, m2, we compare key with a of m2 plus offset. In the first step, no need to consider offset value as it is 0. If key is equal to a of m2, we can say key is found. If key is not equal, now it may be greater than a of m2 or it may be smaller than a of m2. If key value is greater than a of m2, at that time we have to update m as m1, otherwise we have to update m as m2, and we have to repeat the same procedure till m is greater than 1. Once this condition is not true, definitely we can say कि it's absent. Now let us make the analysis of the program. As here we are eliminating the smaller one third fraction of the array each time, therefore time complexity is given as like this. So this is the technique of Fibonacci, sir. Thank you.